Okay, electricity and plumbing students. This is the video where I start showing you how to make wired connections. These will be what we do in our first lab, which will be hands-on in the shop with your own electrical wall. These wires represent cables, and inside those cables, so they have, in our instance, they have white insulation around the outside of them because they're 14 gauge wires. So this is what we call 14-2 wire. There are two current carrying conductors in there. One of them will have black insulation on it. One of them will have white insulation on it. And then there'll be a bare wire in there. That'll be the ground. Okay, so all the wires happen to be 14-2. If they were 12 gauge wires, they'd be a little bit bigger in diameter. Each of the wires inside of them would be a little bit bigger in diameter so they could carry more electricity. And they would have a yellow casing around the outside. So that would be a 12-2 wire if it was 12 gauge, and this so forth. Anyway, so we're going to represent hot electricity with either a black or a red marker. Now, usually it's going to be represented with black unless there are two hot, or what we say, feed wires that are involved with the circuit. This circuit is only going to have black because we don't have any secondary feed wires. Okay, and that'll become more clear as we move forward here. Even though in the wire, this other wire is white, that will be our what we call our neutral wire or our return wire. It is considered what we call a current carrying conductor, but we represent it with orange because it's hard to draw white on white when you have white paper. So we will have orange there, and ground wires are all drawn with green. Okay, so those are the three for this particular drawing, the three we're going to do, or the three colors we're going to use. So for this circuit, this is just a junction box, which all it means is wires will get connected in there. So the wires in this cable will get connected to the wires in this cable. So quite literally, they will be connected. So we're going to take the black wire in this cable, and we're going to connect it to the black wire in this cable. So what we do to represent that is we just go like this. This is a wire nut, and it's tying those two wires together. So this wire connects to that wire, and the black wire is the SEP is our service entry panel. This is where all the breakers are, the little switches in your basement or your garage. When you blow a breaker, that's where it is. You go turn it back on. And the electricity comes in. This is your feed electricity. This is where everything comes from. Okay, then it goes down to here. So we fed our wire down to here. Okay. So I'm going to stick with the black and do all the black connections over to here. Okay. What we're going to do, these are just regular outlets. This is called a duplex outlet. Duplex meaning two, right? And you have two terminals over here. And I would draw these little lines in here because those are what we call tabs. And I'm going to cover this in class and show everybody that. But so if I hook a wire to this, the electricity can flow through that tab over to here in this terminal. Or if I hook a wire here, it can flow to there. That means I can feed both of these hot by hooking one hot wire to one of those terminals. It doesn't even matter which one. Okay, so I'm going to do that because I want both of these just to be hot wired entities. But I also got to get my electricity over to here. So I'm going to take my hot wires. I'm going to hook them together here, just like I did there. But I bring what we call a pigtail off of there, and I hook it to one of the two terminals. So now I have fed hot electricity to that outlet. And then over here, I'm going to take my hot wire and I'm going to feed it there. And I have a tab in there, so that will feed both of these hot. And I am done with my black wire, my black marker. I have fed my feed or hot electricity to everything. So now I'm going to do my neutral wires. These will have white insulation on them. And I'm going to just come here and here. Remember, this is just a junction box. There's nothing else to hook them to. These are outlets, or what we call dual receptacle, duplex receptacles. I'm sorry, I was misspeaking there. Duplex receptacles. They're called that or a switch. They are classified as devices. It's a duplex receptacle device. Notice this electrical box has no devices in it, so it's just a junction box. Okay. So anyway, I get my neutral down to there. I'm going to do the same thing with these neutrals as I did with my hot feed, except for my neutral goes to the other side of the circuit here. And there's a tab in there. So any electricity that goes in will come back out and back to our panel. You have to have a complete circuit. What goes in has to come back. If you don't have a return path, you don't have a complete circuit. And over here, just like that. So now my neutral side is done. Now I have ground. And I'm going to talk more about this later. Ground wires can be bare and not have insulation on because unless there's a function with my system, I shouldn't ever have electricity going through my ground wires. So now we exaggerate these. We draw them all the way out here so that we can see them. They wouldn't be this long. All of this would be shorter. And when you made the connections, you would fold the connections into this electrical box. But we just do this so that we can color code and see where things go. And so I have now made my connections. As you can see, I'll go ahead and use the proper color here. I have my black hot electricity coming in, connecting. So then it now goes down through here, comes out and connects, and it'll go out through that wire, and it will feed my electrical outlet hot. So electricity will come in here. If I have something plugged into that outlet, it'll go in here, out through one of those prongs, out and power whatever it is that I'm powering, and then back and out this wire. And at this point, it'll go back through this wire to my source. That's a complete circuit. Okay. The ground wire doesn't do anything unless there's an overload. And then what it does is it helps carry, we'll talk about this more later, but when you get a short circuit or an overload, electricity starts flowing really fast and your amperage goes way up. And it helps carry those amps back to the source or back to ground before they can do anything. And what happens is it forces them to go through this system and it'll trip the breaker and it'll be safe because it'll shut off the electrical flow. Anyway, we'll talk more about how that works. But as you can see also, I have a return path. I have a return path here that comes over and connects. So it returns there. And then this one returns back from here and goes back. And then it connects here so it can get back to the panel. Same with my green. Works the same way. It's a return path. So that is going to be our first lab. Okay. As you can see, I say it right here. There's one circuit. That means there's one breaker in the box controlling this. There are two duplex receptacles, one here and one here. The feed, that means the electricity comes into this circuit through this junction box. So that's where the feed comes in. The hot electricity comes into the circuit there. And then all the receptacles are continuously hot. In other words, when this breaker is on, all these things are powered. And when you plug something in, they will have power. They can be switched so that they can be switched on and off, but these are not switched. They are continuously hot. Most of your outlets are continuously hot, but sometimes they have switches attached to them. Okay, that's the end of lab 1.